Hey you guys, today we're going to talk about adding and subtracting polynomials. Whenever you add polynomials, all you have to do is combine like terms. Some people like to add polynomials horizontally. Some like to write them in column form and they line up the terms. All I do is just underline like terms and then add them together. No sense in making this complicated. So if we look at this example right here, we have, look for the biggest exponent first. That way when you do it, your answer will be in standard form. So you have 2b cubed, which I can add with 3b cubed because they're both b cubed, so they're like terms. 2 and 3 would be 5b cubed. And now we want to look for squares. We have a positive b squared and a negative 9b squared. So I can put those together because they both have b squareds. Remember, there's a 1 here as a coefficient. 1 plus negative 9 would be negative 8b squared. All right, and then over here, we have a negative 4b, but there's nothing I can put with it over here, so we just drop it like it's hot. So this is our sum. 5b cubed minus 8b squared minus 4b. That's all you do. All you have to do is combine like terms when you add polynomials. Okay, let's look at some more examples. All right, let me zoom out just a little bit. Okay, so for this first one, we have 3x squared minus 4x plus 8 plus 2x minus 7x squared minus 5. So I'm going to start with the x squareds. I have a 3x squared, and I can put that with the negative 7x squared. 3 plus negative 7, different sign, subtract. So that'll be negative 4x squared because the boss is negative. And then we want to look for just x's. I have negative 4x and positive 2x. Negative 4 plus 2 would be, again, different sign, subtract, negative 2x. Then we'll put our constants together. We have positive 8 and a minus 5 or negative 5. 8 plus negative 5 or 8 minus 5 is 3. So the sum would be negative 4x squared minus 2x plus 3. And that's it. You can't put x squares and x's together. They are not like terms. Just for fun, this is a quadratic trinomial. It's quadratic because the degree of this is 2. And it's a trinomial because it has, because it has 1, 2, 3 terms. Just a tidbit there. All right, let's look at the next one. All right, the biggest exponent I have is a 2. So we're going to do our squareds first. We have negative 3n squared. And I can combine that with that positive n squared. Remember, if you don't see a coefficient, the coefficient is 1. Negative 3 plus 1, different sign, subtract, keep the boss. So that'll be negative 2n squared. Now we want to look for a linear term. So we have plus 2n and then a positive 5n. 2 plus 5 is 7. All right, then we'll combine our constants. We have a negative 8 and a positive 13. Negative 8 plus 13, different sign, subtract. The boss is positive, so that'll be plus 5. That's it. Now let's talk about subtraction. All right, when you subtract a polynomial, you can add its additive inverse. And when you first learn how to do positives and negatives, some people call it keep, change, or keep, change, flip, keep, flip, change. I've heard a million different things. Something else that you can do is you can just distribute the negative to these terms. And then after you do that, you just combine like terms the way we did when we added polynomials. So 2 options. You can distribute the negative, or you can do keep, change, change. So the minus will become a plus, positive 7 will become a negative 7, positive 4 will become a negative 4. All right, I'm going to stick with the keep, change, change method, but if you feel more comfortable distributing the negative, it's all the same thing. Once you do that, it's just like addition. All you have to do is combine like terms. So let's do a couple of these. So we're going to do keep, change, And then change, because there's two of them. And then it's just like addition. So the biggest exponent I have is a cube. And there aren't any more cubes. So g cubed, just drop it. And now we want to look for squares. I have a negative 2g squared and a negative g squared. So remember, this would be like a negative 1g squared. So same sign, add and keep. Now we want to look for g's. So we got a 5g and a negative 2g. So 5 minus 2 is a 3g. Okay, and then you have this plus 6 out here all alone. Nothing it can go with, so we're just going to drop it, plus 6. And that's it. Let's look at the next one. Again, it's subtraction, so we're going to do keep, change, and this time we have 3 terms, so it's going to be changeity, change. All right, and then we want to combine like terms. So we've got a 3ax squared. So I have to have an ax squared to put with this. So we're looking. Here's a squared x, but these are not like terms. So there's nothing that can go with my 3ax squared. So I'm just going to drop it. All right. Then we have a negative 5x, so I'm looking for another x. Aha, right here. We have a negative 4x, so same sign, add and keep. That'll be negative 9x. All right, then we have a negative 3a. So I'm looking for just another a. Here's one. So negative 3, negative 6, same sign, add and keep. That'll be negative 9a. We've covered all those. You're left with this booger. And it doesn't have anything that can go with it. So we're just going to drop it here at the end. Plus 8a squared x. And that's it. Let's do a word problem. All right, it says the total number of public school teachers T consists of 2 groups, elementary and secondary, from 85 to 98. Those were some great years. The number in thousands of secondary teachers and total teachers in the U.S. can be modeled by the following equations, where N is the number of years since 85. So S is 11N plus 942. T is 44N plus 2,216 rather. Find an equation that models the number of elementary teachers. So if we have total teachers and secondary teachers, what operation will we have to do to find the elementary teachers? That'll be subtraction. So we'll take the total number, which is 44N plus 2,216. We'll subtract the number of secondary teachers, which is 11N plus 942. And let's see what happens. So we're subtracting. You know what? This time I'm going to distribute the negative. So I'm going to distribute the negative. So I'll have 44N plus 2,216 minus 11N. A negative positive is a negative 942. Now we will combine like terms. So I can put this 44 nuggies minus 11 nuggies, and that'll be 33 nuggies. And then we could also put this positive 2,216 minus 942. So if I do 2,216 minus 942, we get 1,274. So positive 1,274. And that would be the polynomial that represents the number of elementary school teachers. All right, you guys, I hope you have a fabulous rest of the day.